Hello there, and welcome. I'm glad you made your way here. Maybe you're winding down after a long day, or maybe you're the kind of soul who finds comfort in mystery, in vast ideas that drift gently through the mind like clouds at night. Whatever brought you here, you've found a calm place to rest. You don't need to do anything now. Just let yourself breathe. Let your thoughts soften. Let gravity feel a little lighter. Tonight, we're going to fall backward in time, not just through centuries or millennia, but all the way to the very beginning, to the first flicker, to the moment that began everything and yet remains wrapped in silence, the Big Bang. But this won't be a textbook, and it's not a lecture. It's a journey, not through certainty, but through wonder. 100 facts, some known, some strange, all of them real, all of them part of the story we're still learning to tell. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. In the beginning, there wasn't darkness, there wasn't silence, there wasn't even a beginning, at least not in the way we usually imagine one. There was no time ticking, no space stretching, no here, no there, no distance between stars, because stars had not yet come to be. Nothing had form because nothing existed. No clocks, no edges, no waiting, not even emptiness, just the absence of all things. And then, everything. The universe didn't begin with a bang in the way a firework bursts into the night. It didn't erupt into space like an object flung into the void. There was no void, no stage, no canvas. The Big Bang wasn't an explosion in space. It was space itself expanding, unfolding from a pointless point, a nowhere that suddenly became everywhere. All at once, space stretched, time ticked its first moment, and the fabric of reality, impossibly tight and hot, began to breathe. This strange genesis didn't happen in one corner of an infinite backdrop. It didn't bloom from a center like ripples in a pond. It happened everywhere. The whole universe was the origin point, expanding into itself, growing from nothing into everything, with no outside, no surrounding. Wherever you are right now, lying in bed, resting your head, listening in the dark, that spot is one of the places where the Big Bang happened. So is every other. There was no central fireball, no blast to flee from. There was only the birth of space itself, with all its invisible lines stretching outward like taffy pulled in every direction at once. And what of time? If there was no before, what does it even mean to say it began? Time, like space, is not an afterthought. It isn't something that sits beside the universe. It is woven into it. The ticking of seconds, the flowing of moments, the rhythm of change, all of it began as space expanded. Asking what came before the Big Bang is like asking what's north of the North Pole. The question assumes a frame that doesn't exist. Time didn't begin in a moment. It is the moment, the first. But what could have triggered it? What kind of cause could lead to the sudden birth of a cosmos? Here, the mind touches the edge of language. We want to talk about nothing, but the universe is cleverer than our definitions. In quantum terms, nothing doesn't mean the absence of everything. It means the absence of classical things, the absence of stuff. But even in a perfect vacuum, cold, still, stripped bare, there is activity. At the smallest scales, the vacuum bubbles with possibility. Tiny pairs of particles flicker into being and vanish again, like whispers too fast to hear. These are called virtual particles. They cannot be captured. They are not permanent. But they exist, briefly, unpredictably, on the brink between being and not being. This vacuum is not silence. It is a restless field, a canvas of uncertainty, a place where the rules of quantum mechanics allow for momentary flashes of energy, ripples with no source. And some physicists believe it may have been from a quantum vacuum like TH is, some deep, fluctuating field of nothing, that the universe was born. A tiny instability, a wobble, and then a release. You may be imagining a sphere or a pinpoint of light, something small and bright inflating into size. But even that is too solid, too neat. The truth is slipperier. This wasn't something expanding into pre-existing emptiness. This was emptiness gaining dimensions. This was the absence of space becoming space. Before the Big Bang, there was no distance to cross, no moment to wait, no when to hang the question on. What's astonishing is that these quantum effects, so strange and so slight, may have carried within them the spark for a universe. One flicker, stretched and magnified through cosmic inflation, could become an entire cosmos. The scales boggle the mind, from quantum to galactic, from unstable nothing to stars, from a vacuum so close to nothing it almost didn't count, to a world where galaxies spin and suns are born, and you lie here, breathing quietly, listening to the story of it all. The laws of physics themselves seem to emerge with the universe. Gravity, electromagnetism, the strong and weak nuclear forces. None of them predated the Big Bang. They crystallized as space cooled. As the universe unfolded from its initial hot, dense state, symmetries broke and forces separated. It was not just the matter that changed, it was the rules. What we think of as constants may have once been fluid, and what we call the beginning may have been a transformation, not a creation. Still, for all the mathematics and models, there is mystery. There is always mystery. How does something arise from nothing? Was the Big Bang inevitable? Was it unique? Or is this happening, even now, elsewhere? Other bubbles of space, other timelines, other beginnings beyond our cosmic horizon. Perhaps we are one universe in an endless foam. Or perhaps this universe is all there is, stretching into time's farthest reach until the stars dim and silence returns. We cannot see the beginning directly. We only see its fingerprints, the background radiation, the cosmic redshift, the distribution of galaxies across the sky. These are the shadows of a beginning too hot and too fast to record. But here we are, floating in a universe that is expanding still, moving through time that began with that first shimmer. And though we chase equations and satellites and sensors to study the moment of creation, it remains, quietly, stubbornly, beyond full knowing. The beginning wasn't fire. It wasn't even light. It was space and time themselves, unrolling from nothing into everything. No sound, no shape, just potential, blooming into being. And somehow, impossibly, beautifully, you are part of it. The first second of the universe was unlike anything we've ever experienced, and perhaps unlike anything we ever will. It was not the quiet spark of a match or the rising warmth of a sunrise. It was fury and order tangled together, a moment so brief and so wild that it defies not just language but imagination. There were no stars to witness it, no atoms to mark its passing, no place to stand and watch. And yet, everything you see, everything you are, everything that has ever existed, was written in the blueprint of that single second. At the very start, the universe wasn't just hot. It was searing beyond reason. Not millions of degrees, not billions, but trillions. So hot that matter couldn't exist in any familiar form. Protons and neutrons hadn't yet assembled. Even light couldn't travel freely. It was a plasma of pure energy, so dense and chaotic that every particle was smashed against every other, constantly, endlessly, in a seething sea of creation and destruction. Nothing held its shape for long, but something extraordinary happened before that fury could settle. Before even a fraction of a second had passed, in a time frame so small it is almost meaningless to the human mind. Something changed. In the first 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 The universe underwent a period of expansion so rapid it defies the speed of anything we've ever known. Not objects racing through space, but space itself stretching, ballooning outward faster than the speed of light. This wasn't a violation of the rules. Space doesn't move through itself. It expands, and when it does, those limits of speed do not apply. What began as a subatomic speck became something vast enough to give structure to the cosmos. This was the era of inflation, a strange runaway growth where the universe doubled in size again and again and again, all in a fraction of a moment. And with this expansion came smoothness. Ironically, the violence of that instant brought balance. It took the bubbling, uneven chaos of the earliest quantum fluctuations and stretched them across the sky, ironing out wrinkles, making the universe uniform on grand scales. The echo of this smoothing is still seen in the cosmic microwave background, a sky of ancient light still humming with the memory of that time. In this rapidly cooling fireball, particles began to form. Not atoms, not yet, just the raw ingredients, quarks, gluons, electrons, the things that make up all things. For every particle, there was an antiparticle, its equal and opposite, matter and antimatter, created together, bound by symmetry, destined to meet and destroy each other in perfect balance. And for the most part, that's exactly what they did. They collided and vanished, releasing bursts of energy that fed the frenzy of the early universe. But in a strange, vital twist, there was an imbalance. For every billion pairs that vanished, one extra matter particle remained. That lonely imbalance is why you exist, why anything exists. Without it, there would have been no stars, no galaxies, no Earth, no you. Just light, spread thin, in a featureless void. But something in the laws of physics tipped the scales. We don't yet know why. We only know that it did. The universe cooled as it expanded. Not slowly, but fast. Temperatures dropped at a rate no furnace could match. Within millionths of a second, the inferno dimmed just enough to allow quarks to cling together, forming protons and neutrons. These, in time, would become the nuclei of atoms, the raw material of stars, the dust of planets, the building blocks of life. But for now, they floated in a wild soup, colliding, scattering, barely holding together. And still the clock ticked forward. In less than a second, the forces of nature separated. Gravity, the weak nuclear force, the strong force, electromagnetism. What was once a single unified interaction began to fragment. Each force took on its own character, its own laws. The universe began to specialize, to branch, to evolve. The early cosmos was still opaque, still a storm of particles, light, and energy tangled together in motion. But it was no longer chaos without structure. It was beginning to remember shape. It was beginning to write rules. That first second was not gentle. It was not quiet. But it was precise. With every tick of that earliest clock, new possibilities emerged. Expansion slowed, just enough. Temperatures dropped, just enough. Forces settled into balance, just enough. Any more or less, and the universe could have collapsed back in on itself or flown apart too fast for anything to form. But instead, it balanced, perfectly, delicately, unimaginably. And here we are, billions of years later, lying in the dark, trying to imagine that moment, a moment we cannot see, cannot touch, cannot fully grasp, but one we are entirely made from. The first second wasn't a blank canvas. It was a masterpiece painted at the speed of light. Every brushstroke invisible, every color born from heat and symmetry, every curve still echoing in the galaxies that spin above us. You may never remember that moment, but it remembers you. Your atoms were chosen there. Your time began there. The fire cooled, the light scattered, but the pattern remained, and it still burns, quietly, in the spaces between the stars. Long after the firestorm of creation had quieted, after the first second had passed, and the furious expansion had settled into a gentler rhythm, the universe entered an era of waiting. It was still young, only a few 100,000 years old, but no longer wild. Light, which had once been trapped in a thick fog of particles, was still held hostage. Every photon collided endlessly with electrons, scattered in every direction, unable to move more than a fraction of a millimeter without being bounced back again. The universe wasn't dark, but it was blind. No light could travel freely. There was nothing to see, and no one to see it. But with time came cooling, and with cooling came clarity. As the universe expanded, it grew colder, softer. The once furious heat faded to a warmth more subtle, until finally, around 380,000 years after the Big Bang, something delicate happened. The universe became transparent. Electrons slowed and settled into orbit around protons, forming the first atoms, mostly hydrogen, a little helium. With no more free electrons to scatter off of, photons were released. They streamed out in all directions, freed from their ancient prison, carrying with them a snapshot of the cosmos as it was in that precise moment. That light is still traveling. It has never stopped. It stretches with the universe itself, its wavelengths growing longer and cooler as space continues to expand. What began as searing radiation has faded into a faint, cold glow, now just 2.7 degrees above absolute zero. It's called the cosmic microwave background, the CMB, and it is the oldest light we can see. It is not a light you would notice with your eyes. It doesn't shine or flicker or cast shadows on the wall, but it is everywhere. Wraps around the earth, spills into your bedroom, weaves between your fingers as you rest them on the covers. It is in every direction, an ancient echo whispering through the sky. If you could tune a radio to just the right static, you could catch a fragment of it, the hiss of the birth of time, still murmuring across the airwaves. What we see in the CMB is not just light, it is memory. A detailed photograph of the infant universe, taken long before stars were born, long before galaxies spiraled into being. In this map of microwaves, we see a canvas that looks almost uniform, smooth and gentle, as if the cosmos had already been balanced by some invisible hand. But look closer, and you'll find imperfections, tiny ripples, minuscule differences in temperature, mere millionths of a degree. These were not flaws, they were seeds. These fluctuations, random and faint, are what gravity would one day cling to. Denser regions, just slightly more crowded than their neighbors, began to pull matter inward. Over millions of years, those invisible wrinkles deepened, drawing in dust and gas, growing into the skeletons of galaxies. The light we see in the CMB is not light from stars. It is the light from before stars, from before structure. But it holds the blueprint for everything that would come. When scientists first discovered the CMB, they didn't quite know what they had found. Two engineers at Bell Labs were trying to get rid of a mysterious hiss in their radio antenna. They cleaned it, recalibrated, even chased away nesting pigeons, thinking their droppings might be to blame. But the noise wouldn't leave. It was constant, coming from every direction, at all times. What they had stumbled upon, by accident, was the afterglow of creation, the ancient light finally reaching Earth after billions of years. Since then, we've mapped it in incredible detail. Satellites like COBE, WMAP, and Planck have scanned the sky, pixel by pixel, revealing the CMB's delicate texture. With each new image, we see further into the past, reading the earliest chapters of the universe like a story written in heat. The smoothness of the light tells us how inflation sculpted the cosmos. The ripples tell us where the first stars would eventually burn. The temperature tells us how far we've come. And yet, as old as the CMB is, older than any star, older than any atom in your body, It is not the beginning. It is the end of the beginning. A quiet release after a long tension. A sigh after a great labor. It marks the moment the universe became visible, knowable, open to the gaze of future eyes. Everything before it is hidden in shadow. Everything after it is shaped by what it holds. If you could float in space, beyond the pull of Earth, with the right instruments tuned just right, you could measure it yourself. The cold light would pass through you, untouched, unchanged. The same photons, stretching since the dawn of transparency, still moving, still bearing silent witness. They don't speak in words, they don't carry pictures, but they carry truth. They carry the shape of silence, the rhythm of beginnings. The most extraordinary thing is not that we can detect it, it's that we can understand it. That we, born of the very processes the CMB set in motion, can look back across nearly 14 billion years and trace our story to a pattern of tiny temperature differences in a sky of invisible light. That the same ripples we now map with satellites once danced beneath the breath of the newborn cosmos, shaping the galaxies, the stars, the atoms, the molecules, the cells, the thoughts, the dreams, everything. So as you lie there now, letting your mind drift, remember this. The space between your hands is not empty. It is filled with ancient light, still moving. The same light that passed through hydrogen clouds before there were stars, the same light that ripples in the night sky, the same light that sings of the first time the universe let itself be seen. The cosmos remembers, not in stories or songs, but in temperature, in wavelength, in whisper. And it remembers you too. You are part of the pattern it began. You are written in the echoes. If you could have been there, in that vast hot hush, just after light first broke free, you wouldn't have seen much. There were no stars yet, no moons or planets to cast shadows. The universe was still thick with glowing hydrogen and helium, glowing faintly red like embers cooling in the dark. But if you could have listened, not with ears, but with something deeper, you would have heard it. The sound of creation, because the early universe did more than shine. It sang, not like a song you might hum in the shower, or a melody echoing from a faraway speaker. This was deeper, slower, more ancient. The newborn cosmos was filled with pressure. Gravity pulled matter inward, while radiation pushed outward, setting off rhythmic pulses in the plasma sea, ripples that moved through the hot soup of particles like vibrations in a drumhead. These were pressure waves, oscillating through the fabric of the universe itself. They moved not through air, but through matter and light fused together. The universe was dense enough then to carry sound, and for nearly 400,000 years, it rang. These sound waves were enormous, unimaginably slow by our standards. The lowest note would have been many octaves beneath human hearing, with each wave taking hundreds of thousands of years to rise and fall. But they were real. They spread outward like ripples in a pond, building up crests and troughs, compressing and releasing, dancing to a rhythm set by the balance of heat and gravity. As these waves passed through space, they carried energy with them. They gathered matter into denser regions and carved out emptier ones in between. Where they compressed, gravity took hold, pulling more mass inward, planting the seeds of galaxies and clusters. Where they stretched thin, vast voids began to open. These sound waves didn't just echo through the early cosmos. They sculpted it, and though the sound has long faded, its fingerprint remains. We call them baryon acoustic oscillations, faint patterns in the distribution of galaxies, a kind of fossilized rhythm written into the very layout of the universe. Across billions of light years, these patterns still show us where matter was once crowded and where it thinned. By mapping galaxies in every direction, scientists have found the signature spacing, the telltale pulse left behind by those ancient sound waves. Even now, billions of years later, the echoes linger like ripples on a vast, still lake. This structure, the cosmic web of filaments and clusters and vast empty spaces, is a frozen memory of sound. The universe remembers its earliest music, not in notes or lyrics, but in the placement of stars and the curves of galaxies. The architecture of everything we see, from the tiniest dwarf galaxy to the sprawling superclusters, is shaped by that first, slow song. It's easy to think of sound as something delicate, something fleeting, but in those early moments, sound had power. It shaped destiny. It moved mass. It orchestrated the growth of everything that followed. You are here because the universe rang with waves of pressure, because those waves carved structure into the chaos, because gravity followed the rhythm they laid down. The most astonishing part is that we can still see this pattern, not directly, not like starlight, but in the statistics, in the maps, in the quiet distribution of galaxies stretched across the sky. It's like standing in a cathedral and sensing the resonance of a bell that was struck long before you were born, but whose tone still lingers in the walls. The fact that this sound ever existed, that it once pulsed through the cosmos, makes you wonder what else the universe might be saying, what other rhythms it carries just beneath the surface, too vast or too slow for us to hear. But this one, at least, we've found. And once you know it's there, it's hard not to feel it. Not to look up at the stars and wonder if you're seeing not just light, but rhythm. Not just fire, but form. And more than that, it shaped you. The matter that makes your bones, your skin, your breath, your thoughts, was swept up in those early waves. You were never separate from that sound. You are part of it. You are built from it. The hydrogen atoms in your body were forged in that early plasma, compressed and cooled in the wake of ancient vibrations. The gravity that holds you to Earth obeys the scaffolding first laid down by those cosmic oscillations. Even the voids between galaxies, those yawning expanses of nothing, are part of the same silent harmony. We are all caught in the geometry of a song we'll never hear, but which made everything possible. In the end, the sound faded. The universe expanded and cooled, and the medium that carried those waves grew too thin to continue their song. The music stopped, but the shape remained. The silence that followed was not empty. It was filled with structure, with the slow emergence of galaxies and stars and planets and people. The sound passed, but it left behind a universe in tune. Tonight, as you lie still, feel the quiet, and know that beneath it, beneath the hum of distant cities, beneath the wind brushing past your windows, beneath the pulse of your own heartbeat, there is another rhythm, much older, much deeper. It is not gone. It is carried in you. The universe made sound, and then it made you. In the earliest instant, before time had meaning and before space had shape, something happened that shattered the rules of scale. The universe, barely born, expanded not gradually, not gently, but all at once and everywhere, in a burst so sudden and so immense that it dwarfs every explosion that would ever follow. This wasn't matter moving through space. This was space itself stretching, doubling and doubling and doubling again, more than 60 times over, all within a fraction of a second so brief it would be invisible even on a cosmic clock. Inflation, they call it. Not the swelling of a balloon or the blooming of a flower, but an expansion that outran light, a silent surge that pulled the very fabric of reality outward, like taffy. It happened so fast that if you'd blinked, you would have missed not just the moment, but the whole unfolding of scale. A universe smaller than a proton became large enough to contain galaxies. There were no stars yet, no atoms, no boundaries or borders, but there was space, and suddenly, so much more of it. What drove this expansion was not force in any familiar sense. It was energy, steeped into the vacuum itself, something strange, dense, and temporary. A field that filled the universe, smooth and even, with no direction and no variation, like an invisible pressure boiling beneath the surface. They call it the inflaton field, a theoretical substance that may have powered inflation, then vanished just as quickly. No one has ever seen it. No one knows if it was real, but the fingerprints it left behind are carved into the structure of everything. One of the deepest puzzles in cosmology is why the universe looks so uniform in all directions. When we gaze across billions of light years, we see the same density, the same temperature, the same structure everywhere we look. But without inflation, those distant regions could never have been in contact. They're too far apart. There hasn't been enough time for light, or any information at all, to pass between them. And yet, they match. They harmonize. It's as though they shared notes before parting ways. Inflation solves this by stretching a tiny, connected region into the vastness we now observe, giving everything a shared origin, a shared rhythm. The horizon problem, solved not by travel, but by expansion. And then there's the flatness. Our universe, on the grandest scales, isn't curved like a sphere or a saddle. It's flat, balanced so precisely between collapse and runaway expansion that it seems almost unnatural. Any slight curvature at the beginning would have been magnified by time, but we see none. Inflation smoothed out those wrinkles. Like pulling a crumpled sheet taut, it erased any bends, stretched imperfections into invisibility, leaving behind a geometry so even that it defies coincidence. But for all its elegance, inflation remains mysterious. We know what it solves. We can describe its effects, but we do not know why it began or why it stopped. Whatever caused the inflaton field to surge must have also allowed it to decay, releasing its energy into the birth of matter, light, and heat. But the trigger is unknown. Was it quantum instability? A transition from one vacuum state to another? A spontaneous release from something deeper, stranger, older? We don't know, and perhaps we never will. What we do know is that the aftermath of inflation was not silence. It was heat. Tremendous, blinding heat. When the inflaton field decayed, it poured its energy into the universe, reheating it, igniting the next era. The hot Big Bang phase we often think of as the beginning, though it came after the stretching. That heat became particles, and particles became matter, and matter became stars and galaxies and life. But it all began in the cool, silent tension of a universe swelling in every direction faster than the speed of light. Even stranger, some theories suggest that inflation never truly stopped, that in some regions of space it continues endlessly, spawning pocket universes like bubbles in a boiling pot. Ours would be just one. Its inflation ended, its laws settled. But others, countless others, might still be inflating, still stretching, forever beyond our reach. A multiverse, not of science fiction, but of physics, hidden in the folds of possibility. Yet for all its grandeur, inflation leaves behind no roar, no explosion, no visible scar, just a smoothness that shouldn't be there, a flatness that begs explanation, and a lightness of touch that belies the scale of what was done. Tonight, as you rest beneath the slow drift of stars, you are lying in a universe that was once impossibly small. You are made of particles that were born in the release after something vast let go. The space around you, the air between your fingers, the distance between galaxies, it was all shaped in that first flash of scale. And if the inflaton field did exist, then everything you've ever known was once a fluctuation in its silence. You were a ripple, stretched across a newborn void, waiting to become real. We may never see that field. We may never know its origin or its end. But its consequences are everywhere. In the evenness of the sky, in the smoothness of the microwave background, in the gentle, balanced expansion of the cosmos. The great stretch is over. But the space it gave us is still unfolding. And so are we. In the earliest ages of the universe, just after the roar of inflation faded into heat, the cosmos was full of twins. Every time a particle of matter came into existence, an equal and opposite particle of antimatter was born beside it, mirrored in charge, in spin, in fate. They met each other like echoes in reverse, perfect and opposite, and when they collided, they annihilated in a flash of energy, canceling each other in a brilliant farewell. This dance was written into the laws of nature, a balance so precise that it should have ended in emptiness. The universe, on paper, should have unmade itself in its first breath, leaving nothing behind but light. But it didn't. Somehow, against the odds, matter won, barely. For every billion particles of antimatter, there was one extra particle of matter. Just one. Not enough to notice in the fury of those first moments, not enough to disturb the symmetry in motion, but enough to change everything. That tiny imbalance, just a single particle in a sea of self-destruction, became the seed of all things. When the great annihilation swept through the newborn cosmos, matter and antimatter vanished together in brilliant mutual collapse, and the light of their departure filled the skies. But the lonely survivors remained. That one out of every billion is everything. It's the carbon in your body and the iron in your blood. It's the stars in the sky, the dust between galaxies, the ground beneath your feet. It's every atom that ever bonded, every planet that ever cooled, every life that ever wondered. The entire visible universe, all of it, arose from what was left behind when a perfect symmetry broke in the slightest possible way. But why did it break? This remains one of the deepest mysteries in physics. The laws we know today treat matter and antimatter almost identically. The equations are nearly symmetrical, as though reality could have gone either way. And yet, something tipped the scale. Something nudged the universe toward matter. A whisper in the balance, a slight tilt in favor of being. Physicists believe the answer may lie in a phenomenon called CP violation, a tiny crack in the mirror between particles and their opposites. In certain reactions, involving specific particles like kaons and B mesons, the universe shows its hand. The decay of these particles doesn't behave exactly the same when flipped or reversed. The laws are biased, just slightly, toward matter. It's not much. It's a whisper, but it may be enough. Still, even CP violation as we understand it today doesn't fully explain the imbalance. The math doesn't add up. We can see the shadow of the answer, but not its face. It's as though the early universe made a choice and then covered its tracks. Whatever tipped the scales left no obvious signature, only the consequences. But what consequences they are. Without that single extra particle, without that tiny deviation from perfect cancellation, there would be nothing. No galaxies, no stars, no chemistry, no life. The universe would be filled only with radiation, cold and quiet and featureless, a vast, eternal echo chamber of light without form. Instead, we have this: structure, complexity, time, memory. We have you, lying here now, thinking back across the great ages, tracing your own existence to a surplus so slight it almost didn't matter. That's the beauty of it. The universe didn't have to be, not like Teich is. The rules allowed for emptiness. They made space for silence. But something wobbled, something leaned, and from that lean, everything unfolded. It's a reminder that creation doesn't always come in thunder. Sometimes it begins in the smallest of missteps, a tiny imbalance, a barely noticeable tilt. But once it happens, everything that follows carries its echo. That 1 in a billion ripple didn't just survive. It multiplied, collected, formed, evolved. It became the scaffolding for galaxies, the nursery for stars, the platform for life. And ultimately, it became the mind that could look back and wonder why. When you hold your hand to your chest and feel your heartbeat, remember, that beat is matter's quiet victory. When you close your eyes and see the afterglow of memory, know that it rests on a history that might have vanished in a blink. We live in a universe where matter triumphed by the thinnest margin imaginable. We are the consequences of asymmetry, And yet, it doesn't feel accidental, does it? Perhaps the greatest question isn't how it happened, but why it matters. That such a fragile advantage could lead to so much wonder. That out of imbalance, beauty could bloom. That imperfection, in the end, could be the engine of everything. As you drift now, think of the silence that almost was. Then think of the sound of your breath, the weight of your body on the bed, the pull of gravity on the earth beneath you. All of it, a ripple from a time when the universe almost chose nothing, and then didn't. We are not here by certainty. We are here by the slimmest chance, and that chance was enough. In those first few minutes, long before the first star ignited, or the first atom held together a molecule, the universe was a cauldron, not of fire or molten rock, but of particles, loose, rapid, hot, and full of potential. It had cooled just enough after its furious birth for things to begin binding, not with complexity, not with variety, but with simplicity and scale. It was a time of formation, not of things we see around us every day, but of the ingredients that would one day become all things. Big Bang nucleosynthesis, they call it. A mouthful for a moment, so quiet now that it's almost forgotten. But it was here, in a window of just a few short minutes, that the recipe of the cosmos was written. Hydrogen, the lightest element, formed first. One proton, one electron when it finally cooled enough to hold on to one. Simple, elegant, stubborn. Then helium, formed by the union of protons and neutrons, fusing together in the searing heat, like dancers locking arms. This was not a gradual process. The window was narrow, too hot, and the particles would bounce apart before they could hold together. Too cold, and the dance would end before it began. But for those brief minutes, the conditions were just right, just long enough. Roughly 75% hydrogen, 25% helium, trace amounts of deuterium and lithium, scattered like whispers on the wind, and then nothing more. No carbon, no oxygen, no iron or gold. None of the heavy elements that would someday form planets, bones, trees, and teeth. The early universe wasn't ready for those. It didn't have the pressure, the time, the gravity, so it left them undone, waiting. It made a simple base, then moved on. And yet, that simplicity became the foundation of everything. The vast gas clouds that drifted through early space, born of that original recipe, collapsed into stars. And within those stars, heavier elements were finally forged, cooked in the heat and pressure of fusion, layered over eons, then scattered when those same stars exploded in death. But all of that came later. First came the hydrogen, then helium, then the long silence. We still see the fingerprints of that moment. When we look into the deep past, at galaxies far enough away that their light has taken billions of years to reach us, we see those same ratios. The same proportions of hydrogen and helium that formed just after the Big Bang, untouched by stars, untouched by life. It's a confirmation, not just of theory, but of memory, the universe remembering how it began. There's something strangely poetic about the idea that everything we are began with such restraint, that the richness of life, the billions of chemical combinations that form eyes and blood and breath, started with a mixture so basic it barely seems like enough. But that's the elegance of it. The early universe didn't need to be elaborate. It only needed to be patient. It made what it could, then waited for the rest to emerge through time, through gravity, through stars. And so here we are, still breathing hydrogen, still lit by helium-born stars, still wrapped in the legacy of a 3-minute recipe scribbled across a universe that had only just learned to exist. It's humbling to think that the majority of the atoms in your body are hydrogen, the same hydrogen forged in those first moments. They've been here since the beginning, through stars and storms and generations of life. You are older than any mountain, older than any planet. You are made of the lightest element, born in the hottest fire, carried through time by everything that followed. And the helium, though quieter, though less common in your biology, is still part of you too. In the sun's breath, in your lungs when you laugh, in the distant galaxies still glowing with the original composition. It is a constant, gentle reminder of the universe's first act, that moment when energy turned into matter, and matter dared to hold together. The recipe hasn't changed. The ratios are still out there, floating in space, untouched, cosmic relics. Ghosts of a time when everything was new and small and unbelievably fast, when the whole future was compressed into minutes and possibility, and the cosmos decided, gently, without spectacle, to begin assembling the parts. There's something soothing in that simplicity, that the foundation of everything doesn't have to be complicated to be profound, that from just a few basic elements, time and gravity and chance can sculpt worlds. The universe didn't rush. It wasn't in a hurry. It formed what it could and waited for the rest to come together in due course. So tonight, as you breathe, as you rest, as your thoughts drift among stars you may never see, remember this: the atoms that make you were once the fire in that first cauldron. The same hydrogen still burning in distant suns, the same helium drifting in giant clouds across intergalactic space. You are part of the original recipe, a continuation of the first choice. You are not separate from the universe. You are its ingredients. Before the universe had transparency, before light could stretch its limbs and travel across the dark, the cosmos was shrouded in a haze so thick that nothing could move through it unimpeded, not even light itself. The earliest universe wasn't a quiet void. It was a seething, blinding plasma, hot enough to tear apart anything that tried to form. Electrons floated freely, unbound from the atomic nuclei that tried to catch them. And because of this, photons, the particles of light, couldn't move more than a hair's breadth without crashing into one. Every time a photon tried to fly, it collided with a free electron and ricocheted, again and again, millions of times per second, across the entire universe. It was like trying to see through boiling fog. In this early opacity, light was everywhere, but it was trapped. Not in the way a bird might be caged, but more like a storm cloud that can't find the edges of itself. The photons had no clear direction, no open sky. They bounced, scattered, swerved, and swirled, unable to travel far, unable to carry information from one part of the universe to another. There was no visibility, no distance, no view, only motion without clarity. Then came the Great Release, about 380,000 years after the beginning. A heartbeat, cosmically speaking. The universe cooled enough for a delicate and astonishing transition to occur. The plasma began to settle. The chaos began to slow. Temperatures dropped, and in that new calm, electrons began to bind with nuclei. They joined to form the first neutral atoms, and with that, something remarkable happened. The fog lifted. This process is known as recombination. It sounds technical, perhaps even clinical, but what it means is that the universe, for the very first time, became transparent. No longer did light slam into particles at every turn. Now, it could pass freely through space. Now, photons could travel in straight lines, unhindered, carrying the first real images of the cosmos with them. Light was freed, and it has been traveling ever since. Those photons, born in that moment of release, still fill the universe today. They stretch and cool and shift with the expansion of space, but they are still moving, still journeying across the vastness. And some of them reach us. We call it the cosmic microwave background, a soft glow, uniform and faint, bathing the universe in a low-temperature whisper of light. It is not visible to the eye, but it is real, and it is everywhere, between the stars, between your fingers. It is the afterglow of transparency. When we detect that light, we are looking at the universe's first photograph, a picture not taken with a lens or a camera, but with time itself. A portrait of the cosmos when it was just beginning to take shape, when galaxies had not yet formed, when stars were still dreams waiting to burn. It is not sharp. It does not show planets or constellations, but in that faint, dappled glow are the seeds of everything. Tiny fluctuations in temperature, slight differences in density. These would eventually become clusters of galaxies, filaments of matter, the great web of structure that spans the universe. Imagine that. The story of stars, of solar systems, of life, all beginning with variations so small they seem like imperfections in a quiet glow. And yet, that glow is our oldest light, our first window, the earliest whisper of vision. What's even more humbling is that the photons reaching us now from that era are not unique. They're just the ones that happen to be headed our way. Countless others are moving in every direction, toward every point in space, forever. They aren't special because they reach us. They're special because they exist, because they hold within them a memory of the moment the universe became clear. Before this, light was present, but silenced, like a voice in a crowd, lost in the noise. After recombination, light could speak. It could tell stories. It could carry information from place to place, from then to now. In a sense, it is the moment the universe became visible to itself. Before then, there was no horizon, no sense of distance or perspective. But with the freeing of light came the birth of history, of cause and effect across space. It became possible, at last, for one part of the cosmos to witness another. We are, ourselves, beings of light. Our eyes are evolved to detect a tiny sliver of the electromagnetic spectrum, tuned to the kinds of photons that stars produce. But those stars would never have formed without the moment light was set free. Before that, there were no shadows, because there was nothing to cast them, no contrast, no light and dark. Only a blinding soup, endlessly reabsorbed, endlessly scattered. Now, we live in a world full of images, of brightness and nightfall, of sunrise and flame. All of that depends on transparency, on the fact that, long ago, the universe cooled enough to let light go. And so tonight, as you lie still and your mind softens towards sleep, think of those ancient photons, the ones that left their origin nearly 14 billion years ago, drifting through the expanding cosmos until they finally, gently, reached our detectors. They are not loud. They do not shine like the stars, but they have been traveling longer than anything else. They have seen the world before there were eyes to see it. They are not just echoes. They are light, freed at last. After the first light was freed and began its silent journey outward, something else began to move in the darkness. Not with the speed of photons or the brilliance of stars, but with the deep, slow certainty of gravity. It didn't rush. It didn't flash. But it began to pull. In the vast, expanding quiet, the universe was not perfectly smooth. Tiny ripples, mere imperfections in the density of matter, marked the beginning of something monumental. These were not chaotic spikes or cracks. They were delicate variations, so subtle they barely stood out from the average. But gravity does not need drama to do its work. It only needs time. And time, at last, was beginning to stretch out long enough for patience to matter. These tiny overdensities, scattered like freckles across the newborn universe, began to pull. The matter within them, minuscule as it was, exerted its influence on everything nearby. The pull wasn't strong, not yet, but it was constant. Where there was just a little more, gravity made more want to be. Particle by particle, atom by atom, the universe began to lean towards structure. But not all of this pulling came from the matter we know. There was something else, something unseen, already there in great abundance, something that didn't shine, didn't interact with light, and didn't scatter like ordinary particles in the early fire. It slipped through the haze unnoticed, untouched, and yet it was there, forming the scaffolding for everything that would come. Dark matter. We still don't know what it is. We can't see it directly, can't catch it in a detector the way we can with light or even neutrinos. It doesn't glow, doesn't reflect, doesn't slow down when it moves through us. But its fingerprints are everywhere. Galaxies spin the way they do because of it. Galaxies exist at all because of it. It outnumbers normal matter 5-1. And though it remains invisible, its influence is unmistakable. It was dark matter that gave structure its shape, while regular matter was still dealing with light. Bouncing, scattering, struggling to clump, dark matter had already begun to pool. It wasn't hindered by radiation. It didn't need to wait for recombination. It moved freely, responding only to gravity, settling into the first deep wells of potential. These invisible wells became the anchor points, the gravitational seeds that would eventually draw regular matter toward them, like the hidden foundation of a mountain, unseen beneath the earth. Dark matter held space open for the future, and as normal matter cooled and began to fall inward, it followed the invisible hands of dark matter. It didn't know what was guiding it. It didn't need to. It simply fell, softly, slowly, gathering, thickening. Regions that started only slightly denser than average became the beginnings of clouds, filaments, knots. From those knots, galaxies would eventually be born. But all of this took time. For hundreds of millions of years, the clumps grew in silence. There were no stars yet, no light. Only the gentle deepening of gravity wells, pulling gas inward, guided by frameworks that could not be seen. The universe, in its infancy, was already busy building. But in the dark, in secret, in a language we are only beginning to understand. Had there been no dark matter, the universe would have remained smooth. That slight unevenness, those precious ripples in the fabric of the cosmos, would not have been enough on their own. Light, still present, would have pushed too hard, smoothing the matter back out before it could clump. The universe would be a formless sea. No galaxies, no stars, no planets, no people. Just an endless spread of gas, balanced and bland, without feature or future. But that is not the universe we live in. We live in a cosmos shaped by clumping, by imperfection, by the slow, gravitational gathering of matter into places where there was just a little more than average. Structure arose from that. The great cosmic web, stretching across billions of light years, filled with filaments and voids and spirals and collisions, came not from fire or force, but from a patient, invisible hand. And within that structure, stars would one day burn, planets would one day orbit, life would one day wonder. But it all started here, in the dark, with a pull. Tonight, as you rest, imagine those first clumps forming, not with urgency, but with rhythm, not with heat, but with quiet motion. Imagine the early universe drifting, cooling, and slowly curling in on itself, folding matter inward toward centers that could not yet be seen. Picture the silence, the stillness, and the soft pressure of gravity drawing creation into being. Not all stories begin with noise. Some begin with a weight you can't see, a tug in the dark, a shape you don't know is there until something gathers around it. This is how the universe began to structure itself, how the void began to take on form, how emptiness learned to collect. And you, in your body, made of galaxies and time, are here because of that ancient clumping, because gravity, unseen and slow, was never in a hurry, only certain. In the long, dark stretch that followed the freeing of light, the universe settled into something deceptively quiet. Gravity pulled gently on matter, assembling clouds and clumps, but for millions of years, the skies remained black. The earliest structures were invisible scaffolds, delicate webs of gas coalescing in the hollows of dark matter. The stars had not yet arrived. There was no sparkle, no glow, no warmth, but the fading breath of the Big Bang itself. And then, in pockets where the gas grew dense enough and heavy enough, the silence broke. The first stars ignited. They were nothing like the stars we see now. These were giants, titanic, unstable, raw. Born of a universe that had never known light beyond its own cooling glow, these stars emerged pure and powerful, made only from hydrogen and helium. No carbon, no iron, no trace of the elements that later stars carry in their bones. Just the lightest, oldest materials, pressed together under their own weight until fusion burst to life in their cores. They are called Population 3 stars, the first generation. No telescopes have ever seen one, and none exist today. They came and went long before Earth was born, long before galaxies took their elegant shapes, long before time as we understand it had gathered any momentum. Their lives were brief. A few million years, perhaps, just a flash on the timeline of the cosmos. But in that flash, they changed everything. In their burning hearts, those stars began a new kind of alchemy. Hydrogen fused into helium, and helium into heavier elements. Not just heat and light, but matter itself began to change. For the first time, atoms heavier than helium were created. Carbon, oxygen, nitrogen, the seeds of complexity. Not many, not yet, but enough to begin a story that would stretch across billions of years. And when these massive stars died, which they all did, violently, they did not fade gently. They exploded, their cores collapsing and their outer layers flung into space with unimaginable force. Supernovae, scattering the elements they had made into the interstellar medium. These were the first enrichments of the cosmos. Until then, space had been clean, pristine, simple. But these deaths painted it with ash and color, with the raw material of future worlds. From their destruction came creation. The gas that had once been hydrogen and helium alone was now mixed with trace elements. Tiny amounts, but enough to cool more quickly, to collapse more easily, to birth stars with longer lives and greater variety. These were the second generation, the children of the giants. And from them, eventually, came stars, like our sun, planets, life. But it started here, in fire that had never burned before. The first stars lit up the cosmos not just with visible light, but with energy that reshaped the environment around them. Their ultraviolet radiation began to ionize the hydrogen that filled the universe, piercing the darkness and changing the chemistry of space itself. They pushed back the fog of the cosmic dark ages, replacing it with an expanding glow. Slowly, the universe transitioned from shadow to illumination, from silence to song. It's hard to overstate how dramatic their arrival was. Before them, the universe was a place of potential but no form, gravity without radiance. And then, suddenly, there were points of light scattered across the sky, brilliant and alone, burning with a heat no modern star can match. Their mass made them unstable, their brightness fierce, but it also made them fertile. In dying so quickly, they gave more than they took. The heavy elements they created did not disappear with them. They were left behind, drifting through space, waiting to be used again. And so, when you look at the stars now, when you see the soft glow of constellations or the radiant pulse of a sun, you are not just witnessing light, you are witnessing inheritance. The calcium in your bones, the oxygen in your lungs, the iron in your blood. None of it existed before those first stars died. You are a descendant of explosions, a product of short-lived giants who never saw a galaxy but helped build them anyway. Their deaths were the price of your existence. That's the strange, solemn rhythm of the universe. Things are born in silence, burn in brilliance, and end in violence. And from those endings come beginnings that couldn't have happened any other way. The first stars taught the cosmos how to shine. They forged the first elements of complexity and then gave them back, freely, destructively, generously. They didn't last, but they didn't need to. Their legacy isn't in their longevity. It's in everything that came after. Tonight, as you lie still and let the hush of the world settle over you, Remember that the stars you see are not the first. They are echoes, descendants. Their light carries the memory of giants. And in you, in every breath, every cell, that memory lives on. You are made from the ashes of the first fire. In the long sweep of cosmic time, even a few 100 million years can feel like a heartbeat. But after the silence of the dark ages and the brief brilliance of the first stars, something new began to gather. Not just clumps of matter or scattered bursts of light, but structure on a grander scale. Clusters of stars, stitched together by gravity into the earliest galaxies. These were the first cities of the cosmos, built from the ashes of ancient fire, forming in the wake of violence and flame. They didn't look like the galaxies we know today. There were no elegant spirals yet, no vast, smooth disks or majestic elliptical sweeps. These first galaxies were smaller, messier, like cosmic scaffolding still under construction. Their shapes were clumpy and irregular, their light uneven, as if the universe itself was still learning how to organize beauty. And in a way, it was. These early structures were experiments in gravity's architecture, raw, fragile, chaotic. Yet within them, stars burned, new generations formed, elements mixed and swirled and cooled. And over time, the chaos softened into patterns. The light from these first galaxies still travels, crossing billions of light years to reach us. And when it arrives, we see not what those galaxies have become, but what they once were. Ancient flickers from a cosmos still stumbling through its infancy. The Hubble Space Telescope, floating high above Earth's atmosphere, has caught some of this light. In its images, we glimpse the distant past, whole galaxies caught in moments they outgrew long ago. It's not like looking at a photograph of someone you know. It's like looking at a childhood portrait of someone you've never met. Unfamiliar, yet hauntingly familiar. Because you know, in time, what they became. These galaxies, strange and untamed, grew slowly. Billions of years passed. Mergers happened. Smaller galaxies collided and combined, drawn together by gravity's quiet insistence. Each collision disrupted and remade them, stars thrown into new orbits, clouds compressed into fresh waves of star birth. It was a dance of destruction and creation, violence and rebirth. And out of this dance came the shapes we recognize now. Spirals winding with grace, ellipticals glowing like ancient embers, irregulars still holding the echo of the universe's wild youth. You are part of one of those galaxies now. The Milky Way, vast and glowing, is the product of that same long history. It too was once smaller. It too was shaped by collisions and time. Its spiral arms, studded with stars and nebulae, are not static. They move, they shift, they change. They are the result of countless interactions, guided by dark matter and deep time. And the light it sheds now will one day travel across unimaginable distances, arriving in the eyes or instruments of watchers we cannot imagine. Watchers who will see us not as we are, but as we were. Because that's the nature of light in this vast cosmos. Everything we see in space is memory. A record etched in photons, stretched across the distance like a message in a bottle thrown into a cosmic sea. Even the closest star takes years to speak to us. The farthest galaxies whisper across 13 billion years. Time and space are tangled in every image. We look out, and we look back. The universe reveals itself in glimpses, and always through a veil of history. There's a softness to that idea, if you let it sink in. A kind of grace in knowing that the light we receive is a gift from the past, ancient, patient, enduring. Galaxies were born, grew, merged, and moved on, and yet they still reach us, still tell their story in silent waves of light. The cosmos is not in a rush to be seen. It simply waits, glowing quietly, letting its light find us in time. And as galaxies formed and matured, they became the great habitats of creation. Within them, stars were born by the billions. Planets took shape in swirling disks. Moons circled, comets drifted, and chemistry began its long, intricate dance toward complexity. Galaxies weren't just containers for stars. They were engines of transformation, carrying within them the ingredients for life, scattered across the void. Tonight, as you rest, you are inside one of these galaxies, drifting through its spiral arm at incredible speed, though you don't feel it. You're orbiting a star that orbits a center, surrounded by hundreds of billions of other stars, all humming along in quiet rhythm. You are part of that structure, a thread in that vast tapestry, woven by time and gravity and chance. And somewhere out there, in the light from a distant galaxy just now reaching us, another story is unfolding. Not in real time, not as it is now, but as it was. A record of a beginning, preserved in the long travel of light. That light may pass through telescopes, or skies, or even through you. It doesn't need permission. It just arrives, softly, bearing the memory of when everything began to take shape. Galaxies began as chaos, but they learned grace. They carry the past within them, and in their light, we glimpse the beauty of becoming. The universe didn't just explode into being. It grew into structure, into form, into quiet order, and it continues still. There's a kind of music in the dark, though it isn't made of sound as we know it. It doesn't travel on air or bounce off walls or carry the shape of a voice. It doesn't whisper, doesn't roar, and yet it's there. A low, aching resonance that may have been echoing since the very beginning. Not the beginning of a song, or a moment, or even of time as we measure it, but the beginning of everything. A vibration that started when the universe was still breathless and wild, barely born, a tremble through space-time itself. Gravitational waves are not like light. They do not scatter. They do not fade as quickly. They stretch the very fabric of the cosmos, warping space in the subtlest of ways. Not across moments, but across ages. Long after the light of the first stars has dimmed and cooled, long after galaxies collide and collapse, these waves may still ripple outward, untouched, unchanged. They are the most enduring echoes of creation. Scientists have already detected gravitational waves, tremors from the collisions of black holes, the death spiral of neutron stars, events that happened far away and long ago, and yet still rang loudly enough to be heard by instruments here on Earth, as a ripple no wider than a fraction of a proton. It's a kind of listening that requires stillness, patience, and silence so deep it borders on devotion. And even with that, we've only begun to tune in. But those waves, the ones we've heard, are the loud ones, the ones born from cataclysm. What if there are older waves, fainter, softer, woven into the structure of space itself? What if the Big Bang didn't just shine, but shook? What if inflation, that moment when the universe expanded faster than light, left behind not just a stretch in distance, but a kind of shiver in the bones of the cosmos? Some believe those waves still move through us, brushing past planets and stars, unnoticed not because they are gone, but because we have not yet learned how to listen well enough. Unlike sound, they carry no tone. Unlike light, they hold no color. They are pure distortion, subtle, ancient, almost ghostly. But in them may be hidden the fingerprint of the universe's birth, the signature of that impossible first second when space exploded into being and time began to unfold. To detect them would be to listen to the oldest story ever told, not with ears, but with instruments so sensitive they must ignore everything else. Machines suspended by lasers, arms miles long, measuring the tiniest twitch of space, hoping to catch the faintest echo, like standing in a cathedral and waiting for a whisper uttered before the walls were even built. And if we hear them, what would they say? They might reveal the truth of inflation, how it started, how it ended, why it happened at all. They could confirm that space once bloomed in a fraction of a second, multiplying faster than light itself. They might tell us about the conditions before matter, before energy, before any known force had settled into place. They might show us not just the edges of the visible universe, but the seams of reality beneath it, a pattern, a vibration, a hidden rhythm guiding everything. Some have imagined the universe as a kind of bell. When struck by creation, it rang, and it has been ringing ever since, though most of us have forgotten how to hear it. That ring wouldn't be audible to any being. It wouldn't sway trees or shatter glass. It would swell and fall inside the scaffolding of existence itself. A deep, resonant pulse that reminds everything that it came from something, that it was set into motion, that it still carries that motion in its bones. You might be feeling it now without knowing. You might be moving with it, gently, subtly, like a buoy on an ocean so vast you cannot see the shore. You might be part of the ring, part of the wave, part of the echo that never stopped. And that's the quiet wonder of it, because in all our science, all our calculation and precision, we're still children pressing our ears to the ground, listening for thunder from the past. We build machines to still the world around us, to hear through the noise, to find the softest voices hidden in space-time. And with each faint detection, each wave recorded and decoded, we take another step toward hearing the deepest hum of the cosmos. Not a voice, not a message, just a presence, a motion, a memory. It's humbling to think that something so ancient could still be with us, that the birth of everything might still vibrate through the quietest places, that the universe itself might never have stopped ringing. Maybe you can't hear it with your ears, but if you close your eyes and let your thoughts drift past the edge of sound, you might sense something underneath it all. A low, endless thrum, pulsing not in air, but in time, not in music, but in meaning, the echo of a beginning that never truly ended, the softest evidence that everything is still in motion, still unfolding, still trembling with the weight of its own origin, and that you, somehow, are part of that song. Imagine a sea with no shore, a boundless expanse where space itself is like a field of boiling water, and from each rising bubble, a new universe is born. Not metaphorically, but physically, mathematically, possibly. This is one of the stranger paths our understanding of the cosmos has led us down. An idea not invented by fantasy, but invited by equations, hinted at by the very physics that describe how our own universe began. It's called eternal inflation, and if it's right, then the Big Bang was not a unique event. It was local, specific, one bloom in an eternal field of blossoming space. According to this view, inflation, the rapid, exponential expansion that occurred just after the birth of our universe, never truly stopped. Not everywhere. In some regions, it slowed and cooled and gave rise to the kind of universe we see around us: galaxies, stars, atoms, light. But in others, it continues, endlessly stretching, endlessly spawning new pockets of calm where new Big Bangs unfold. Our universe, vast though it seems, might be just one bubble in an infinite cosmic froth. Each bubble sealed off from the others by walls of inflating space, too distant and expanding too quickly for any signal to pass between. It's a deeply disorienting idea. We've only just begun to grasp the scale of our own universe, the sheer scope of billions of galaxies spread across trillions of light years. To imagine that this might be just one of countless universes, not metaphorical alternate realities, but real physical domains with their own rules, their own timelines, their own physics, is to push the mind beyond comfort. And yet, the mathematics allows it. In fact, the mathematics seems to prefer it. Within this framework, the laws of physics themselves may not be universal, what we think of as constants. The strength of gravity, the speed of light, the masses of elementary particles may be local settings, tuned differently in other bubbles. In one, stars might form from particles we can't imagine. In another, time might flow in ways that would break our understanding. There may be universes without matter at all, or without space, or where nothing ever cools, or where life arises in structures entirely unlike anything carbon has ever dreamed of. And still, they could be real. We may never see them. The space between universes is not like the space between stars. It's not a vacuum you can travel through. It's a wall of inflating space, stretching faster than light, keeping each universe isolated like lanterns floating in separate, sealed jars. There may be no crossing, no contact, no echoes. Just the quiet mathematics, suggesting that the story of everything might not be a single book, but a library. Infinite, unreadable, unreachable, and yet still there. It's hard to say what this means for us. We are creatures of one cosmos, built from the dust of one Big Bang. We know no other sky. But to consider that our universe, in all its majesty and mystery, might not be all there is, that it might be one tile in an endless mosaic, does something to the way we think about meaning, about rarity, about chance. The conditions that allowed you to exist, to think, to wonder, may have required a very particular balance of forces and particles. If there are infinite universes, then perhaps somewhere, every possible variation is played out. Somewhere, the dice landed differently. Somewhere, there was no Earth, no stars, no space between. And yet, here you are. That's not something to dismiss, or even explain away. It's something to sit with. Like all good mysteries, it asks more than it answers. It suggests that your existence may be simultaneously inevitable and impossibly rare, that the universe you know is both typical and precious, that this bubble, your bubble, is one expression of something far greater, something not reducible to one story, one shape, or even one logic. Scientists don't claim to know if this is true. The multiverse, for all its elegance, remains theoretical. We have no way yet to detect other universes, no experiment that can peer through the walls of our own, and maybe we never will. Maybe it's a cosmic horizon that cannot be crossed. But still, the equations whisper, the models hint, the logic holds. That alone is remarkable, because the same mathematics that lets you predict how a ball will fall or a planet will orbit now reaches out toward realities beyond your own. The tools we use to launch satellites and build bridges also point toward other worlds, not worlds of fantasy, but of physical possibility. The multiverse isn't magic. It's what happens when you let inflation run too long and let physics play out in every direction it can. It's easy to feel small in the face of all three, to imagine yourself as one speck in one universe among uncountable others. But there's another way to see it, not as a story of insignificance, but as one of context. You are not the center of everything, but you are part of something vast, something unbounded. You are one note in a cosmic symphony so large it may never end. And the song you sing, though quiet, is part of that music. If there are other universes, they may never know you exist, but you know, you're here, thinking, wondering, listening to the silence between stars and the whispers of theory. You are a product of this bubble, a rare emergence from its specific laws, its particular beginning. You are, in a very real way, one of the ways this universe becomes aware of itself. And if there are others, if there are infinite beginnings scattered like sparks across an eternal field, then maybe the miracle isn't that you are alone. It's that you're here at all, before the first light, before the first breath of space or flicker of time. There may have been something, or maybe not. Maybe before is the wrong word altogether, a trick of language that crumbles under the weight of a question it was never built to carry. We are used to thinking in terms of cause and effect, past and future, beginnings and ends. So it's natural to ask, what came before the Big Bang? But in the strange silence at the edge of everything, even that question begins to dissolve. According to some theories, The Big Bang wasn't truly the beginning, not in the way we often imagine it. It may have been a transition, a threshold, a moment of becoming that rose out of something deeper and older. There are hints, slivers, mathematical whispers suggesting that our universe may have emerged from a prior state, a different configuration of reality, not an empty nothing, but a something so unfamiliar we don't yet have the words to describe it. This is where physics bends into philosophy, where equations stretch toward metaphysics, and where certainty gives way to awe. Loop quantum cosmology, for instance, proposes that before the bang, there was a collapse, not a destruction, but a bounce, a universe that contracted inward until it reached a limit, then rebounded into expansion. If this is true, then what we call the Big Bang wasn't the origin of existence, but the turning point of a cycle, like the moment when a pendulum halts in its descent and begins to swing back. The math suggests that space and time themselves may have a granular structure woven from loops and quanta so small they evade all detection. And in this tightly curved geometry, a singularity, the infinite point of density we once imagined, is replaced by a bounce, a heartbeat, a rhythm. String theory paints a different picture, one not of loops but of vibrating filaments, 10 or even 11 dimensions curled around themselves. In this vision, our universe is one sheet, a three-dimensional membrane floating in a higher dimensional space. It may have collided with another membrane, triggering the energy that became our cosmos. Or it may simply be one expression among many, a node in a vast and ancient multiverse where Big Bangs flicker like sparks in a fire without a center. Time, in this view, doesn't begin with our universe. It stretches out across a deeper landscape, timeless in its totality, but full of births and endings inside its folds. Still, despite these elegant models, we don't know. We might never know. Because if time itself began with the Big Bang, then asking what came before is like asking what's north of the North Pole. The question collapses under its own assumptions. In our universe, time is tied to space, interwoven with the shape of gravity and the flow of energy. If there was no space, no time, no matter, then before might not be a meaningful concept at all. The universe may not have a past. It may simply have a beginning. And yet, the human mind doesn't like to stop there. We are compelled to keep asking, to keep imagining, even if the answers shimmer just beyond our reach. Perhaps it's because everything we know begins from something else. Every story, every life, every tree, every star. We instinctively search for origins behind origins, nesting them like dolls until we hit the final mystery. And here it is, vast and still and glowing with questions. What came before? Maybe it's not about answers. Maybe it's about sitting with the unknowable and feeling its shape press against the inside of our understanding. Maybe the power of these questions is not in their resolution, but in their ability to open us, to expand our perception, to soften the boundaries of what we think is possible. Because even if we never touch the moment before time, we can still feel its echo. The Big Bang left its mark, not just in radiation and expansion, but in curiosity, in wonder, in the drive to reach further. So what if the universe did bounce? What if there was a universe before ours, different in form, but bound to us through that moment of transition? What if there were many such bounces, countless cosmological lives, cycling through death and rebirth like breaths? What if the multiverse has no beginning, no edge, no final curtain, only layers of unfolding possibility? Or what if this is the only one, the only show, the only time the curtain ever rose? The truth is, we are still in the middle of the mystery. We have names for the boundaries: inflation, singularity, Planck time. But names are not explanations. They are lanterns in the fog, beautiful, flickering, partial. We are building instruments that reach closer, detectors that may someday catch the afterglow of a bounce or the ripple of an earlier age. But until then, the past before the past, remains hidden, and perhaps it should. Perhaps some mysteries are meant to hold us in stillness, not push us forward, to remind us that the universe is not a puzzle to be solved, but a presence to be encountered. A vastness that exceeds our grasp not because it mocks us, but because it invites us. It invites us to listen, to wonder, to exist in the quiet tension between knowing and not knowing. So let the question linger. Let it stretch out into the dark like a thread you can follow with your fingertips, never quite reaching the end. Let it soften the certainty of beginnings and teach you that mystery is not absence, but depth. That even the question, what came before, is a kind of poetry, and that somewhere, woven into the silence of space, might be the rhythm of a story older than time. Imagine standing on an endless plain. No hills, no valleys, just a smooth stretch of land that goes on forever, perfectly even, horizon to horizon. Now imagine that instead of walking across it, you're living inside it, not on top, but within. This is the kind of space the universe might be. Vast, smooth, immeasurable in reach, and flat. Not flat like a page or a pancake, but flat in the language of geometry, where parallel lines never meet, where the rules of distance and direction remain unbent by curves. It's strange to think of the cosmos in terms of shape, but in physics, geometry is not decoration. It is structure, logic, truth. And right now, the best measurements we have tell us that the universe is flat, geometrically flat, with only the slightest room for doubt. But that flatness is not trivial. It's profound, because the shape of space doesn't just describe how things are arranged. It whispers something deeper, the future. In cosmology, shape is fate. If the universe were positively curved, like the surface of a sphere, then its destiny would be to eventually stop expanding, to reverse course, and to collapse back inward in a final crunch. If it were negatively curved, like a saddle, then expansion would continue forever, but in a way that grows more and more open, more stretched, as if the very fabric of reality were unraveling into infinite dispersal. But if the universe is truly flat, then the story is more balanced. Expansion continues forever, but not wildly, just steadily, coolly, like a breath that never quite ends. That flatness is a kind of cosmic tightrope, a razor-thin line where gravity and expansion have danced into a delicate harmony. And somehow, impossibly, we seem to be on that line. But it raises a question that presses against the edges of our understanding. How? The early universe had every reason to be curved, wildly so. Yet here we are, billions of years later, measuring that the angles of the largest cosmic triangles still add up to 180 degrees, as if the cosmos itself has been carefully ironed flat. This is part of the so-called flatness problem, one of the reasons inflation theory was born. That brief, staggering burst of exponential expansion in the earliest moments may have smoothed the universe into flatness, stretching any initial wrinkles across such an immense scale that the whole thing appears geometrically even, like a balloon inflated so far its surface feels flat to someone standing on it. But here's the unsettling part. We can only see so far. Our observable universe, that shimmering bubble of light, about 93 billion light-years across, is not the whole story. It's just the part we can touch with photons. Beyond that, we don't know. Space could curve out there, gently or wildly. The true shape of the entire universe might only be hinted at within our cosmic horizon, like trying to guess the form of a vast sculpture by examining just a sliver. Maybe space bends, but the curve is so shallow it escapes detection. Or maybe it's exactly flat, a perfect infinite plane in every direction. Or maybe it's closed and loops back on itself in a way we can't yet grasp, where traveling far enough in one direction could, in theory, return you to your starting point, like walking the surface of a globe without ever falling off the edge. And then there's this. What if the shape isn't even constant? What if space is shifting subtly over time? Or if its large-scale geometry is shaped not just by matter and energy, but by deeper rules we haven't yet uncovered? Because space, in Einstein's theory, is not a backdrop. It's a participant. It bends and flexes in response to gravity. It warps around mass. It stretches as the universe expands. Geometry is not a stage. It is alive. And in this living structure, even the flatness we measure might be a momentary illusion, a still frame in a moving film whose final act remains unwritten. There's a quiet humility in this kind of science, a recognition that our tools, powerful as they are, reach only so far. We build satellites that peer into the afterglow of the Big Bang, charting tiny variations in temperature across the sky. We map galaxies and measure the angles between them, tracing triangles across the void like ancient surveyors of a cosmic land. And from all of this, we infer a shape not with perfect certainty, but with care, with rigor, with awe. It matters, this shape, because it guides everything. The growth of galaxies, the ultimate fate of stars, the slow cooling of cosmic radiation. If the universe is flat, then its expansion will slow, but never stop. Light will stretch, heat will fade, stars will die, and black holes will evaporate. In trillions of years, the universe will become dim and sparse, a sea of cold particles drifting through darkened space. But if the shape is something else, curved, closed, hidden in ways we can't yet detect, the ending might be different, more sudden, more cyclical, or perhaps more strange. So tonight, as you rest, picture it, the shape of everything, not just what you can see, but what lies beyond, the way the stars are arranged, the quiet angles between galaxies, the grand scaffolding of gravity and expansion that holds us in place. This is the architecture of reality, not just the story of where we are, but the story of where we're going, and we are still drawing the map. Far across the sky, in regions so distant they lie beyond the reach of any signal, we see the same quiet hum of heat, the same soft pattern of temperature and texture that graces our own corner of the cosmos. These opposite ends of the universe, billions of light years apart, glow with nearly identical warmth, a relic of the early fire, stretched thin and dimmed by time, but still astonishingly uniform. And yet, by the logic of light and distance, they should have never spoken, never touched, never shared even the smallest whisper across the abyss. That's the puzzle at the heart of the horizon problem. In its infancy, the universe was small, hot, and dense, a bubbling fog of particles and radiation. As it expanded, it cooled, and when it became transparent, that ancient light began its journey through space. We call it the cosmic microwave background, a fossil glow, the oldest light we can see. But that light carries with it a message, that the early universe, even in places that should have been strangers, was eerily, perfectly coordinated. The same temperature, the same structure, the same sky, written twice, in places too far apart to ever have agreed on anything. Imagine two people waking up on opposite sides of the world, each wearing the same clothes, humming the same song, remembering the same dream, despite having never met. The odds of such coincidence stretch reason. And yet, in the vast stretch of the cosmos, that's precisely what we see. Distant galaxies bathed in the same primordial fire, cooled to the same degree, as though they had long ago shared a quiet conversation and reached an agreement about how the universe should look. But how could they have spoken? How could information, energy, heat, light have traveled between them when there was never enough time for a signal to cross? The speed of light sets a strict boundary, and yet the cosmos seems to have cheated. This is where inflation steps in. Inflation is the idea that, in the earliest moments, a fraction of a second after the Big Bang, the universe didn't just expand, it surged. Space itself ballooned outward, exponentially, like a breath held in and then released all at once. In that brief instant, a tiny region, small enough for all its parts to touch and share information, was stretched into something vast, unrecognizable, and cold. The distant regions we now see on opposite ends of the sky were once neighbors. They spoke, aligned, reached equilibrium, and then were pulled apart so quickly that they lost contact forever. Inflation didn't just make the universe big, it made it smooth. It took the tiny wrinkles of the early cosmos and flattened them over immense distances. It turned a room of whispering voices into a silent cathedral, where the echoes have long faded, but the symmetry remains. Without inflation, the uniformity of the universe is a riddle with no solution. It asks us to believe in coincidence on a scale that defies logic, that all these distant regions just happen to start out exactly the same without ever having a chance to coordinate. But with inflation, the mystery shifts. Now we ask not why the universe is smooth, but how inflation began. What set it off? What field or force caused space to stretch faster than the speed of light? Not breaking any rules, but bending them, because it wasn't matter moving through space, but space itself expanding. We invoke something called the inflaton field, a hypothetical entity that may have driven this great unfolding. But we don't know what it is, we don't know how it works, and we don't know what stopped it. And still, the evidence gently nudges us toward belief. We see the fingerprints of inflation in the cosmic background, in the patterns of galaxies, in the distribution of temperature fluctuations across the sky. Each tiny echo, each statistical quirk, offers a hint that something grand and silent once reshaped the universe in an instant. But it's not a proof, it's a whisper, a suggestion, a glimpse through the keyhole of an ancient door that may never fully open. That's what makes this so haunting. The smoothness of the cosmos, the uniformity that makes the night sky feel orderly and calm, may be the result of a moment we can never witness. A transformation that happened so quickly, so early, and so thoroughly that it left behind only shadows. It's like finding a room perfectly set, candles lit, chairs arranged, music playing, and wondering how it all came to be when no one was there. The elegance of it is undeniable, but the mechanism remains unseen. And maybe that's part of the beauty, that even in the age of telescopes and satellites and equations carved into chalkboards, we are still sitting with mysteries that feel more like poetry than proof. That the grandest smoothness we've ever observed, the shared temperature of a universe too large for its own coherence, might be the afterglow of a secret that space itself is keeping. So tonight, as you rest beneath your own small patch of sky, imagine those distant corners, places beyond your reach, beyond any ship or signal. They look like here, they feel like now, and somehow, impossibly, they carry the same quiet memory. A memory of being one, a memory of a time before division, before distance, before the fabric of space was pulled tight and scattered wide. They are echoes of a closeness we no longer see, but the harmony remains. The beginning wasn't loud. It wasn't even sudden, not in any way that time would recognize. Because there was no time, not really. No ticking clock, no pulse to measure the moment, no witness to say when before gave way to after. Instead, there was a hush, so profound that calling it silence would be too much. There was no ear to hear it, no fabric of space to carry the echo, no coordinates to point to and say, it happened here. There was only a ripple, a shimmer, a tiny tremble of nothingness, so brief and so faint that it should have vanished and never returned. But it didn't vanish. It inflated, and now it's everything. The idea seems impossible at first, almost reckless, that all the galaxies and stars and nebulae, every black hole, every breath, every planet and mountain and child and song, began with a flicker smaller than an atom, a tremor not of matter, but of probability, a quantum fluctuation. The kind of randomness that lives deep inside reality, where particles can appear from nothing, briefly borrow energy from the void, and disappear before the universe notices. Except this one didn't disappear. It expanded. Space swelled. Time stretched. And the flicker became a cosmos. In quantum mechanics, certainty is a luxury you don't get to keep. At the smallest scales, particles don't have precise locations, just a fog of possibilities, a field of maybe. The vacuum, what we casually call empty space, is anything but empty. It roils with virtual particles, momentary ghosts that flash into being and cancel themselves out. The whole thing jitters, like the surface of a pond catching the breeze. That jitter, the tiny randomness baked into existence itself, might have been the seed, not just of stars, not just of galaxies, but of everything. It's strange to think that the grand sweep of the universe, the spiral arms of the Milky Way, the gravitational ballet of clusters, the bright roar of quasars, and the slow drift of continents, traces back to fluctuations so small they defy imagery. These weren't bumps in matter. There was no matter yet. They were bumps in possibility, woven into the quantum fields that underlie reality, born from rules that allow the impossible, so long as it's brief. But one fluctuation wasn't brief. It rode the wave of inflation, stretched to cosmic scales, and froze into the scaffolding of the universe. The galaxies we see now are not random. They were shaped by these early tremors. Slight overdensities in the field became knots of gravity. The knots pulled in gas, which formed stars, which died and birthed heavier elements, which gathered into planets, which wrote poetry and built telescopes and asked questions like, "TH is," all from something so impossibly tiny that it didn't even have a location, just a ripple, caught in the act of becoming. But something waits at the intersection of these ideas. And it's not easy, because to speak of the beginning, to describe that place where quantum randomness meets the curve of space and the mass of galaxies, you must bring together two great truths that refuse to share the same room: quantum mechanics and general relativity. The two pillars of modern physics. One governs the very small, with its probabilities and superpositions and particles that are also waves. The other governs the very large, with its smooth curves and elegant geodesics, the slow dance of planets and the warping of time. Each one brilliant, each one correct, and each one utterly incompatible with the other when it matters most. At the beginning, in that first breathless instant, when the universe was no larger than a proton and expanding faster than light, both laws must have applied, but we can't describe how. Not yet, not completely. We lack the bridge, the unifying equation, the theory of quantum gravity. Some whisper it might be string theory, weaving particles from vibrating loops. Others place their bets on loop quantum gravity, where space itself is granular, built from discrete quanta. Some think the answer lies beyond dimensions we can see, curled up so tightly that even light can't reach them. But for now, the full picture is still out of reach. The map fades at the edges, and yet we stand in the aftermath of that unknowable moment. Everything we see, every spiral galaxy, every infant star, every echo of microwave light is shaped by the pattern of those quantum ripples. Like frost on glass, they etched their signature into the sky, slightly warmer here, slightly denser there, a randomness that became structure, a fuzziness that gave rise to form. Without it, the universe would be smooth, lifeless, a sea without waves. It is precisely because of the jitter, the imperfection, the quiet chaos at the root of things, that anything exists at all. And perhaps most astonishing of all is this: the entire visible universe, the vast arena of space and time we can observe, billions of galaxies across billions of light years, might have emerged from one of those tiny fluctuations. A puff of borrowed energy, amplified by inflation, stabilized by cooling, sculpted by gravity, and now written into the fabric of everything. Not a fireball, but a whisper. Not a bang, but a bloom. It's tempting to search for meaning in that, to imagine intention behind the randomness. But perhaps the deeper wonder is that it needed no intent. That from a place beyond time, where laws and logic flickered like flame, a universe unfolded, not because it was planned, but because it could, because quantum fields hum, and sometimes they hum just right. So when you gaze into the night sky and feel its depth stretch around you, know this: it was once smaller than a dust mote. Its story begins not with stars or atoms or even space, but with a shimmer at the edge of nothing, a ripple in the silence. And from that ripple came the song, "The world moves forward, always forward." Milk swirls into coffee and never unmixes. Ashes fall from flame, not the other way around. Children grow into adults, not the reverse. The past is filled with memories, and the future is made of guesses. This is the arrow of time, quiet, relentless, and inescapable. We live inside its current. We sleep and wake, we build and break, we say goodbye. But where did this arrow come from, and why does it point the way it does? In the great unfolding of the cosmos, the Big Bang wasn't just the beginning of space. It was the beginning of time itself. Not a clock ticking into a ready-made emptiness, but the creation of the clock and the emptiness both. From that first instant, time began to move in one direction, and it hasn't stopped. This directionality, this asymmetry between past and future, is not written into most of the laws of physics. At their core, many equations work just as well in reverse. A pendulum swinging back is as mathematically sound as one swinging forward. But the universe doesn't behave that way. It remembers. It accumulates change. It drifts from simplicity into complexity, from smoothness into disorder. This is entropy. At the heart of time's arrow is this idea: entropy increases. It's the principle that order tends to give way to chaos, that systems move from neat arrangements into messier ones unless energy is added to maintain the structure. Ice melts, paint peels, stars burn through their fuel and collapse. The universe, over time, becomes less organized, more diffuse, more entropic. But here is the paradox. If the cosmos is sliding downhill, then it must have started at the top. It must have begun in a state of extraordinarily low entropy. And that is the mystery, the early universe. That searing, expanding fog of particles and light was hot, dense, and in many ways, wild. But in terms of entropy, it was oddly tidy. Its particles were spread nearly evenly, its geometry flat, its structure simple. This is not the expected starting point. Statistically, a high entropy beginning would be far more likely. A universe full of black holes and clumps and chaos should be the rule, not the exception. But that's not what we find. We find a cosmos that was balanced delicately on the edge of perfect symmetry, and then tumbled forward. Why? No one knows. Some suggest that entropy is gravitationally strange, that a smooth distribution of matter in space is actually low entropy when gravity is involved, and that as clumps form into galaxies and stars, the entropy rises. Others look to inflation, to the sudden stretching of the universe that may have ironed out wrinkles and left things unnaturally pristine. Still others say this is just how things began, and that we may never understand why. The past is locked. The dice were cast before there was anyone to throw them. But this arrow, this steady direction, is not just a curiosity of physics. It shapes everything we experience. The expansion of the universe adds to it. As space grows, the cosmos becomes cooler, more spread out, more entropic. The stretch adds room for entropy to increase, and so the arrow points onward. The flow of time may be entwined with this expansion, like a thread woven into the fabric of space itself. Perhaps time moves forward because space does. Perhaps they are the same unfolding. Then again, what happens if the unfolding reverses? Some theories suggest the universe might not expand forever, that dark energy might lose its grip, or that gravity might eventually win. If the cosmos begins to contract, to shrink inward rather than stretch outward, would time itself begin to flow backward? Would entropy decrease as space collapses? Would milk unmix and memories undo themselves? Or would the arrow persist, still pointing toward more disorder, even as the walls of space cave in? No one can say. There are models that predict a bouncing universe, one that expands, contracts, and expands again in an eternal cycle. But each bounce resets the arrow. Time's direction, tied not to motion, but to entropy, flips at the turnaround. In those models, every collapsing universe forgets the one before it. The memory is lost in the crunch. And yet, here we are, creatures of the middle, not at the beginning, not at the end, but suspended in the drift. We remember the past. We imagine the future. We are tuned to the arrow. Our biology, our psychology, our language, all of it flows with time. We age, we forget, we record. The forward direction is not just a cosmic detail. It's the frame of our lives, a river in which everything floats. And still, it began with something strange. The deepest mystery is not why time flows, but why it flows from such an ordered state. Why, at the moment of its birth, the universe was poised on the edge of improbability, with so little entropy that the arrow could even exist. We do not know. The question may live outside our tools, beyond our logic. It might be one of those truths that remain unanswered, not because we haven't asked well, but because the asking itself is bound to time. And time was born in the asking. What we do know is this: the arrow still points. It carries us toward unknown futures, toward wider dispersals of energy and simpler states of being. Stars will burn out. Galaxies will drift apart. The cosmos will fade into cold and quiet, unless something intervenes, unless there is more. But we move forward, always forward. The arrow holds, and in its path, we find wonder. The light you see tonight from the stars, soft as whispers and scattered like breadcrumbs across the sky, is not from now, it's from then. Every twinkle is a message that left on its journey long before you were born, before your parents were born, before the continents looked quite the way they do now. Some of it began its flight when Earth was nothing but a molten dream. Some of it started even earlier. The oldest photons we've ever captured began their journey over 13 billion years ago, back when the universe was a fraction of its current age and space itself was still heavy with the afterglow of birth. When you look at the sky, you are not seeing space. You are seeing time, because light doesn't arrive instantly. It travels, and it takes its time. At 299,792 kilometers per second, it moves faster than anything we know, but in the scale of the cosmos, even that is slow. It means that the farther away an object is, the longer its light takes to get here. So a galaxy a billion light years away is a billion years in the past, captured not in its current form, but in the form it wore when that light first escaped its stars. A photograph developed in the darkroom of space. That means we don't see the universe as it is. We see it as it was. We live surrounded by ancient ghosts. Some of those galaxies, those dazzling pinwheels of fire and dust, may no longer exist. Their stars could have gone cold. Their arms could have merged with others, or torn apart in collisions too distant to yet be visible. The light we catch in our telescopes is just the echo, still arriving long after the source may have faded. We reach back in time with every lens we aim skyward, peering into a past so distant it defies imagination. And yet, we see it. The Hubble Space Telescope, perched just above our blue world, has peered deep into what's called the Hubble Ultra Deep Field, a patch of sky so small it could be covered by a grain of sand held at arm's length. And yet, In that tiny space, it found thousands of galaxies, each a cradle of stars, each a memory of what was. We see them as they were when the universe was just a few 100 million years old, when the first structures were still forming, when the sky itself was still young and unsure of its shape. And the deeper we look, the younger the universe appears. We wind back the cosmic clock, layer by layer, like peeling paint from an old wall. First, the modern galaxies, then the ancient ones, then the great reionization, when the first light began to burn away the fog, then the darkness, the silence, the murk of the newborn universe. And finally, if we could look far enough, perhaps the beginning itself. But even our best instruments cannot see everything. There is a wall, a boundary we cannot cross with light. Before 380,000 years after the Big Bang, the universe was opaque. Light could not travel freely. Photons scattered constantly off particles in the dense, hot soup of early matter, like headlights in fog. So when we look to the edge of the observable universe, we do not see the Big Bang itself. We see the moment the fog cleared, the cosmic microwave background, the first light that could move through space without being stopped. Everything beyond that is hidden, not because it didn't exist, but because light was not yet free. Still, we try to push the boundary. Every new telescope, every advance in infrared or radio or gravitational wave detection is an extension of our vision. These aren't just machines. They are time machines. They let us see what once was. They let us build a map of the ancient sky, and each image they send back is an artifact, not of space, but of time. Every pixel is an echo, a delay, a shadow thrown across billions of years. It's strange to think that we exist in a kind of cosmic present that no one else can share. No part of the universe knows us as we are. We are invisible in real time to nearly everything. If distant civilizations are looking our way, they aren't seeing us. They're seeing dinosaurs, or perhaps nothing at all. And if they see us in the future, long after we're gone, they'll see echoes of our moment, just as we see the echoes of theirs. Time in the universe is not a shared stage. It's a sequence of private performances, each one seen only by those in the right place at the right distance. The cosmos is filled with a billion plays unfolding at once, each audience slightly out of sync. Each star you see is a memoir. Each galaxy is a letter delivered late. And yet, all of this is how we know what we know. Because light travels, because it takes time, because the cosmos doesn't hide its age, we can study its youth. We can glimpse what once was. The starlight that grazes your eye may have traveled longer than Earth has existed, carrying with it stories too vast for one lifetime, too deep for one species. It tells us where we came from. It reminds us how small we are and how connected. So the next time you look up, remember this. The night sky is not a window. It's a mirror held to the past, a canvas where time is painted in layers of fire and silence, a place where the dead still shine and where every flicker is a journey, long, slow, and impossibly beautiful. The stars do not twinkle. They remember. The universe is not drifting apart gently. It is accelerating. Galaxies are not just coasting away from each other in silence. They are picking up speed, as if pushed by an unseen hand. This is not what we expected. For a long time, the assumption was simple. The Big Bang hurled everything outward, and gravity, tireless and patient, would one day rein it all back in. Maybe the universe would stop expanding. Maybe it would reverse. Maybe it would collapse into itself, a cosmic breath drawn back inward, ending as it began. But that's not what's happening. The more we look, the more we see. The expansion isn't slowing down, it's speeding up. The galaxies aren't retreating at a constant pace. They're sprinting, stretching the fabric of space faster with every passing moment. Something is driving this acceleration, something immense and inexplicable. We call it dark energy, not because we understand it, but because we don't. It's a name that fills the silence where knowledge should be. Dark energy isn't like gravity. It doesn't pull, it pushes. It acts not on objects, but on space itself, stretching the emptiness, expanding the gaps, thinning the connections between islands of matter. It is everywhere, evenly distributed, and it doesn't dilute as the universe grows. In fact, the more space there is, the more dark energy there is, and the more powerful its influence becomes. A feedback loop written into the bones of reality. No one knows what it is. We have equations. We have models. We can measure the rate of expansion, track the drift of galaxies, chart the redshift of distant light. But the essence of dark energy remains beyond reach. It's like listening to a symphony and hearing a note that doesn't belong, a note that keeps getting louder, even as the orchestra fades. It doesn't match anything else we know, and yet, it may decide the fate of everything. If it continues as it is now, constant, persistent, unchanging, then the universe will end not in fire, but in frost. This is the big freeze, a future where galaxies accelerate so far apart that they vanish from each other's view. Stars will die one by one, their light fading into the black. Planets will grow cold. Atoms will decay. Time will stretch thinner and thinner until it becomes almost meaningless. The universe will become a sea of darkness, silence, and infinite loneliness. If dark energy grows stronger over time, if its repulsive force increases, then the end may be far more violent. This is the Big Rip. In that scenario, galaxies aren't just pulled apart, they are torn apart. Clusters unravel, stars are dragged from orbits, planets crack and dissolve. Even molecules and atoms themselves are eventually ripped asunder, victims of the accelerating expansion. Space doesn't just stretch, it shreds. And then, there are possibilities, stranger still. Perhaps dark energy will fade. Perhaps it will reverse, and gravity will reclaim its throne. Perhaps we'll see a big crunch, where everything collapses inward, heat rising again as matter is compressed into an unimaginable singularity, a mirror of the beginning. Or perhaps the universe will bounce, collapse, giving way to another explosion, another creation, another arrow of time, an endless cycle, each act erasing the memory of the last. We do not know. All we know is now. And now, we live in a time unlike any before. A time when the universe is still young enough for stars to burn, for galaxies to shine, for life to think and dream. We live in an era when the cosmos is still visible, still full of light. In the far future, that won't be true. The expansion will carry most galaxies so far from us that their light will never reach us again. The universe will seem empty, even though it is not. Astronomers of the far future may see nothing at all, unaware that their night sky was once filled with a billion flames. We are lucky, in a strange and quiet way, to be here now, to witness the sky while it still sings. And yet, the ending, whatever shape it takes, will echo the beginning. Not in form, perhaps, but in feeling. A silence too large to fill, a boundary beyond which we cannot see, a mystery wrapped in darkness. The universe was born with a question on its lips, and it will end the same way, unfinished, unanswered, unfolding into a final, beautiful silence. And in that silence, perhaps there will be another spark, or perhaps not. But until then, the galaxies keep drifting, space keeps stretching, the cosmic fabric thins and flows, carrying us farther into the unknown. Time moves forward, light grows dimmer, and the mystery deepens, not because we know less, but because the closer we get to the edge, the wider it becomes. The end is not a wall, it is a horizon, and we are sailing toward it. You are not apart from the cosmos. You are not merely a passenger in its vastness, observing from a quiet corner, untouched. You are woven from it, not in metaphor, but in matter. Your body, this warm and thinking thing, is stitched from remnants of a fire so ancient, so immense, that its light still drifts through the fabric of space. That fire was the Big Bang. It was the first breath, the first heartbeat, the first note of a symphony that has never stopped playing. And somehow, impossibly, that breath became you, the iron in your blood. It did not begin here. It did not form in your body, or even in Earth. It was built in the core of a star that lived and died long before our solar system was born. The calcium in your teeth, the oxygen in your lungs, the carbon that forms the frame of your cells, they were born in the furnaces of long-gone giants. And those giants were born from clouds of gas and dust, and those clouds came from the cooled remains of the first atoms, and those atoms were forged in the moments after the bang, in the seconds when the universe was still learning how to be. Every part of you is an echo, not just your flesh and bone, but your thoughts, your wonder, that quiet spark behind your eyes, the one that looks at stars and asks why. That, too, is a ripple from the beginning. The Big Bang did not just create matter. It made possibility. It made a universe that could eventually fold in on itself in thought. It created the space where minds could form and question and dream. It built you out of silence and left the mystery intact, just enough that you'd want to understand it. You are not a mistake. You are not a coincidence. You are a consequence of everything that came before. A chain reaction 13.8 billion years long, with each link necessary, each step inevitable. And that chain, somehow, reached your doorstep, your hands, your breath. You are not just made of the Big Bang. You are made by it. The atoms that compose you have traveled through time. They've been in the hearts of stars, the depths of oceans, the bones of other creatures. They've been scattered by supernovae, pulled into gravity's arms, melted and reformed and born again. You are a mosaic of histories, a library of particles with stories longer than Earth itself. And yet, here they are, speaking through you, living, briefly, as you. The universe has spent almost 14 billion years getting to this moment, not just to now, but to you, resting, breathing, listening, and it's still going, still stretching, still making, still moving towards something no one can quite name. There's no final page, no last chapter. You are not at the end of the story. You are part of the story, writing itself. And when you sleep, when your body quiets and your mind floats in that strange, soft tide between waking and dream, the universe does not stop. Stars are still being born. Galaxies are still spinning. Light is still traveling, still telling ancient tales across impossible distances. Somewhere, a photon that left a dying star before Earth had oceans is just now brushing the edge of a telescope's lens. Somewhere, a new planet is cooling in the dark. Somewhere, the echo of the bang still hums in the background, softer than silence but still there, still singing. And you are one of its verses. You are what happens when the universe turns inward and asks itself a question. You are curiosity made flesh, wonder given shape, a fleeting constellation of thought and feeling, bound together for a short time, and yet long enough to marvel, long enough to love, long enough to know that you are here, that this happened. So rest now. Let the weight of the stars slide from your shoulders. Let your breath slow to the rhythm of drifting galaxies. Let your thoughts unfurl like nebulae, soft and slow and glowing at the edges. You don't need to understand it all tonight. You don't need to carry the whole sky. Just know this. You are a tiny, brilliant whisper in a story so ancient it has no beginning, so vast it has no edge, and so beautiful it cannot be fully told, but it can be felt. And right now, it's feeling itself through you.